Okay, so last day we were watching the uniform rectilinear motion, and I start to talk you about the uniform accelerated rectilinear motion. This motion is has an acceleration, but that acceleration is uniform. Okay, so the acceleration is constant, but velocity or speed is not going to be constant. It's going to be increasing or decreasing, but with a constant acceleration. And now I want you to take care with the graphs. Okay, I'm going to compare graphs of uniform rectilinear motion and graph of uniform accelerated rectilinear motion. So you remember that here we have a position time graph, okay, and a speed time graph. Position time graph is like this. The position increases or decreases, okay, if it comes to the reference point, it decreases, but in general position increases as the time goes by. Okay, position increases, and the speed is constant. So the speed is going to be, for example, 5 meters per second. So the speed is going to be constant. As the time goes by, the speed is constant. It's always the same value. Okay? Take care when you see a graph, okay? Here is always the time, but here it can be a position time graph or speed time graph. Last day I start to talk you about this one. When the movement is accelerated, position is going to increase as the time goes by, okay? But it's going to increase more and more and more faster. So it's going to be something like this. As the time goes by, the object is going to accelerate. The position increases, okay? But if you take a look at the 1, 2, 3, 4, 5, 6, okay? In the first 3 seconds, position increases. I want to say 1, 2, 3, 4, 5, 6 meters. Okay? In the first 3 seconds, position is going to increase only 1 meter, but in the second 3 seconds, okay, position is going to increase from here to here. It's going to increase from 2 to 6. Can you see that now the object is moving faster? Okay, it's moving faster. At the beginning, it increased its position in 3 seconds. It increased its position in 1 meter. But here you can see that in the next 3 seconds, it increases in 4 meters. Okay, so it's an accelerated movement. This is what we see in the position time graph, okay? And if we go to a speed time graph, okay, you are going to see that the speed is going to increase, okay? But it's accelerated uniform, so acceleration is going to be always the same. So velocity is going to increase always in the same proportion. So the graph is going to be something like this. This is meters per second, okay? And 1, 2, 3, 4, 5. So if the object starts when it's stopped, the velocity or speed is going to be 0. And as the time goes by, velocity is going to increase. It's going to increase in a regular basis, okay? It's uniform, the increasing. So in the first second, it increased 1 meter per second. In the second second, it increased 2 meters per second, okay? It increases, well, in a regular basis. So I want you to take care of the graphs. It's really important that when you see this graph, okay, you have to take a note this please, because it's important that when you see this graph, it's probable that you mistake and you think that this graph is this one. So you have to take a look to this and this. You have to take care if it's a position time graph or a speed time graph, because you can mistake the position time graph with the speed time graph. This one belongs to this type of motion. And finally, the formulas we've been using are: in uniform rectilinear motion, we use the formula of the speed, okay? Velocity equals final position minus initial position divided into time. This is the formula we are going to use with this kind of motion. And in this kind of motion, we are going to use the formula of acceleration, okay? Acceleration is going to be the final speed minus initial speed divided into time. This is the one we are going to use with this kind of motion. Units: international system, meters per seconds, and in this one, units are going to be meters per square seconds. Take care, square seconds, okay? Why? Because here we have the position, which is in meters, and the time that is in seconds, meters per second. But here we have the velocity, and velocity is meters per second, and here the time is in seconds. So we have seconds twice. So that's the reason why the unit is in square seconds. So this is the base for doing all problems, okay? Now we are going to start doing some problems in page 112. No, sorry, 114. So we are going to do first one, which is 41. Mauro, we've been seeing in lesson 5 this movement, and now we are starting to learn this one, okay? I'm going to erase this one. I hope I have enough space here. 41. On a test track, a car goes from 0 to 108 kilometers per hour in 10 seconds. Okay, this is the 41. So I want you to give some time for doing this exercise. Okay, you have to use this formula, and I wait for you. Okay, I wait for you. So just start doing it.